So igneous petrology, it is the study of igneous rock. In simple say, it is the study of igneous rock. So what is an igneous rock? It is a primary rock that crystallizes directly from magma. And what is a magma? So it is a molten material which is formed by the melting of lithosphere or mantle. So igneous rock, obviously it is a primary rock that is directly crystallized from the magma. Magma is very important for igneous rock. So most of the case में तुम्हारा जो तेरा magma crystallize करे বা solidify हुए when it will ascend to the surface but at the temperature decrease करे solidify वाला मैंने जो rock produce करे that is your igneous rock. So first में देखिए what are the different characteristics of magma. So an igneous rock that in any crystalline or glassy rock that forms from cooling of a magma. So magma, it is formed by the partial melting of lithospheric plate or mantle material. So magma can cool to form igneous rock either on the surface or below the surface. So कहते हो तुम्हारा magma जोटा कि surface person as volcano, then they will cool there, solidify there to produce igneous rock that हम extrusive कहवा, or sometimes they also solidify in the subsurface region beneath the surface region that is called as your plutonic or intrusive igneous rock. So broadly तुम्हें igneous rock को it can be divided into extrusive and intrusive. So all the form from the magma. So what are the different characteristics of the magma that we'll study? First, so what are the characteristics of magma? What are the types of magma? So magma can be divided into three types on the basis of their silica percentage, SiO2 percentage. So one is rhyolitic magma, what we call acidic magma. Rhyolitic is called acidic magma, which is the SiO2 content of greater than 65%, you can say. Simple, greater than 65%. So if any magma that contains silica percent greater than 65, it is considered rhyolitic magma. So it can be very low in FeFg and Ca content, but high in potassium and sodium content. It will be alkali. Then andesitic magma, it is intermediate in composition by intermediate magma, which have a silica percentage of 55 to 65.8%, and in all components, it contains all component in intermediate composition. Then basaltic magma, where SiO2 percentage 45 to 55%, which contain Fe, Mg, Ca in abundant amount and potassium and sodium in least amount. So basaltic magma, it is less denser, or it has less viscosity because the silica percentage is less. So these are three types of magma. Then what are the gases that are present within the magma, or what we'll say volatile content? So only remember there are many volatile contents. Among the volatile content, H2O is the most abundant one. About 90 to 95% among the volatile is water vapor, then carbon dioxide, then you'll find sulfur, chlorine, or HCl, SO2, H2SO4. All this notation will be found in the volatile content of the magma. But mostly it is H2. So all the dissolved gases, when we come to the surface, they will release. They will help to form vesicles within the igneous rock. যদি volatile content আছে সব জায়গায় release হয়ে যায়, so vesicles produce. Should I that will discuss in form and structure. So what is the temperature of magma? So among the magma, the three types of magma, basaltic magma is the hottest one. It has a temperature of 1000 degree to 1200 degrees centigrade, and andesitic magma has 800 to 1000 degrees centigrade. Then rhyolitic magma, it has a temperature of 650 to 800 degrees centigrade. So other than that, a basaltic magma obviously it has 1000 to 1200 degrees centigrade. Those are abundant, but sometimes you'll get a magma having temperature 1500 degree to 1600 degree. So those type of magma is called as your kimberlite magma. You can also get magma having temperature 600 degree. That is called carbonatite magma. Kimberlite, carbonatite. These are very rare magma. So 1500 to 1600 you will get kimberlite magma. It is a very high temperature, and carbonatite is a very low temperature. When it comes to viscosity. So viscosity is the resistance to flow. So what are the different factors we'll consider that will affect the viscosity of the magma? First, higher SiO2 content. If magma have higher SiO2 content, then magma will have higher viscosity. So that means viscosity increases with increase in SiO2 concentration in the magma. The low temperature magma have higher viscosity because in case of higher temperature there will be more randomness, there will be more separation between molecule. And the temperature बढ़ेगा so the randomness so the entropy increase करे. So the molecular distance बढ़े so that will decrease the viscosity. So the temperature हम अधिक दबा viscosity से decrease करे. The SiO2 it is directly proportional to viscosity. Temperature is inversely proportional to viscosity. The higher the temperature, the lower the viscosity. In terms of volatile content also tends to reduce the viscosity of the magma. The, that means if you add volatile content, that will reduce the temperature of the reduce the viscosity of the magma. So that means volatile content is inversely proportional to the viscosity. The more you add volatile content to a magma, it will have less viscosity. That means dry magma are more viscous than wet magma. So dry magmas are more viscous than wet magma. So another thing affect that is saying O L O linkage. as you go down the bounce action series, you see olivine, then at last you will get quartz. So olivine that crystallize in nesosilicate, quartz that crystallize in framer silicate but tectosilicate. So olivine that is characterized by an isolated tetrahedral structure where it doesn't share its oxygen with other tetrahedral. It doesn't share its oxygen with other tetrahedral. Suppose they are like this, they doesn't share their tetrahedral, but quarks it share all of its tetrahedral. So they think that they will be more crowded in a particular place. So what particular place is more crowded in it. So that ki they are যদি তোমার SiO লিংকেজ যেতে ইনক্রিজ করছে বা ALO লিংকেজ যেতে ইনক্রিজ করছে ডাউন দ্য সিরিজ that will increase the viscosity. সেটা কোন ইনক্রিজ করবে viscosity ইনক্রিজ করবে. So SiO ALO linkage always increases the viscosity. Next come to there are some cation modifier like you can say Mg, Fe. Those are things that present within the structure of the magma. Sorry, within the structure of the silicate. Within the structure of the silicate, they will help to can say ki link they will link the silicate structures or ALO polymerase. They try to complicate the structure. I mean, sometimes tetrahedrals or linkage they are joined by these cations. It is we have started in case of mineralogy, mineral structure, where the silicate structures or the structures of different minerals they are joined by cations. Like this, you can see there are cations here. So they tend to complete the structure. They tend to complete means कि इसमें join होला वाला जगह फंका रहे है तो सेटा that will decrease the viscosity. सेटा उसका viscosity को decrease करे. So these are different characteristic different factors that will affect the viscosity of the magma. So density. Density, it is mass by volume. Density difference that helps to the magma, that helps magma to rise to the surface. Density difference. Suppose at a particular depth, magma is forming. So newly formed magma has lesser density than the surrounding rock. So that's why it will tend to rise. Rise because of the density difference between the newly formed magma and the surrounding country rock. So that's why density difference plays an important role during ascent of the magma. जेहेतु magma तर surface को rise करियो तार depth decrease करियो and it will start to crystallize. Crystallize करियो start करियो. So magma कितने high rise करियो that is calculated by this formula. r into d rho m into h. Rho r is the average density of the rock column through which magma will rise. D is depth of magma, rho m, that is the density of the magma. H is the height of the magma, height to which magma will rise. So this is the magma chamber. Here, this is the surface. This is your D. Suppose it is rising to this level, it is on the rise kala magma ta. This is also H. Then average density of this column total will be rho r, and density of the magma will be rho m. So rho D is 400, density rho C is 2.7, rho m is 2.65. So gram per centimeter cube rachi rho r into D equal to rho m into H. So H is your rho r into D, the rho C of the 2.7 into 400 by 2.65 will be 392.6. This much it will rise. Generation of basaltic magma. How the magmas are formed? Because ki magma are not found everywhere on the earth. So only a particular region where magma will generate and will form a volcano. So what are the different conditions that will the magma will form only on that region? That we will study here. How the magmas are generated in the magma of the generation. So these are the different setting. First, this is a normal situation or normal crust. So in a normal crust, as you go down or to the subsurface region, the geothermal will increase. So on the upper coastal level, it is 25 degree to 35 degree per kilometer. It will increase. That is geothermal. The geotherm, it is not alone increase the heat so that the lithosphere or crustal material that will melt. तो जियोथर्म एतिके टेम्परेचर देई पारेनि जे कि तुम सब सरफेस रे जते तळକୁ ଯିବ सॉलिडस रे सॉरी मोर जे लिथोस्फेरिक पार्ट मेल्ट कर त हम जते तळକୁ जाउ टेम्परेचर सेते बढुची तो एई जगह धर गोटे सॉलिड अछि यार मेल्टिंग टेम्परेचर जति कि जियोथर्म एई जगह रे सेति के टेम्परेचर इंक्रीज कराई पारे ना सेति पे तमरो का होवे सब जगह तुम वोल्केनो पाइबो नै बिकॉज़ जियोथर्म इट इज नॉट सफिशिएंट alone it is not sufficient to increase the temperature so that the substance will melt. So this is the solidus temperature. मैंने आ तल को सॉलिड रही ऊपर को मेल्ट रही जो जो जगह टेम्परेचर सपोज धर कि at 50 kilometer depth temperature is actually this much but it required this much of temperature to melt. So geothermal it cannot provide that much of temperature to melt the solid part, to melt the lithospheric part. There are certain places where these occur. So there are two conditions where melt will occur. Either this geothermal will increase to the solidus, जो जगह बहुत अधिक टेम्परेचर जो कौन से कारण जो तो जियोथर्मल सॉलिडस को टच करिवो तो एटी मेल्टिंग स्टार्ट हो माने गोटे जगह कौन सी रीजन जो जियोथर्म सडनली बढ़ी जिवो बा टेम्परेचर सडनली बढ़ी जिवो तो सेठी जो सब्सटेंस हो ताल मेल्ट कर पारि. This is the condition you can say if geothermal is suddenly increasing, and this is also the same condition, it is suddenly increasing, it is gradually increasing. Another condition, the solidus will change. आंकर मेल्टिंग टेम्परेचर कमी जीव ताले माने जियोथर्म को टच कर दीटा कंडीशन ने लिथोस्फेरिक पार्ट रा मेल्ट हे परिबो मेंटल पार्ट रा मेल्ट हे परिबो. Once they will melted they will generate magma, they will rise to the surface को rise. So those are condition को जगह पे one midocenic divergent plate boundary hotspot and on the convergent plate boundary. So what happens in the midocenic ridge? So this is one plate here. So lithosphere plate, so convection current is going on like this. So convection current, it brings the hotter material to the shallow region like this. This part is hot, this part is can say cool, little cooler, the hotter. So when our mantle material will get hot here, they will rise, they will gradually rise to the surface and become cooler here. Then again they will sink, then become hotter. This is convection current. On way during convection current, the hotter material rise to the shallower level at a very slow rate. So when they will rise, the magma they will scatter all their heat. The heat was lost way during rising because of slow rising. तो धीरे धीरे राइज कर धीरे धीरे मटेरियल का हीट लॉस कर चलছে कौन रीजन जो दिस हॉट मटेरियल है ना हॉटर मटेरियल दे राइज टू द शैलोअर लेवल सडनली राइज टू द शैलोअर लेवल सडनली सपोज धर कि तुम कौन गोटे धर चाह आने जाइए गोटे मार्केट रू गरम जब धीरे धीरे आसला चाटा ठंडा हो मार्केट रू तुमको चाटा गरम रखार अच्छे तुम जल्दी आस घर को तो सो दैट कि चाटा गरम रुम जिते जल्दी घर पहुँचो से तो अधिक गरम से भाया कंडीशन में जब देखा तो कन्वेक्शन कर सैलोअर लेवल को आसूसी से तार टेम्परेचर रिलीज कर दूसरी तार टेम्परेचर लॉस हो जाए सो सी जगार जो हिट टाक एठिक आनी पारे कहीं आणला बेलू कूलर हो जाए ठंडा हो जाए जदि ये प्लेटा सडनली ब्रेक कर प्लेटा यदि सडनली ब्रेक कर सी जो प्रेसराइज कर से प्रेसरटा रिलीज कर सडनली ऊपर को राइज विदाउट लूजिंग हिट कहते आडियाबेटिकल तो यदि सडनली ये जगह राइज कर जगार टेम्परेचर सडनली इंक्रीज कर टेम्परेचर सडनली इंक्रीज कर तो सडनली इंक्रीज कर तो ये मटेरियल पूरा मेल्ट हवा स्टार्ट कर तो ऑटोमेटिक मेल्टिंग कर बा तुम कहि परिबो डीकंप्रेशनल मेल्टिंग when magma will suddenly rise to the shallower level or hotter magma, they will rise to a shallower level without losing heat. So that will increase the gradient there, and the lithospheric part or mantle part there, they are able to melt and generate magma, and then it will eventually come to the surface as volcano to form new plates there. So take it divergent plate boundary of it. So that's why in this divergent boundary condition, at a very shallower level, the geotherm suddenly increases and it will toss the solidus, and melting will begin. Same thing it happens in hotspot region where mantle plume rise from d double dash layer to the lithospheric plate, and it will all the magma they will inside here, and all the heat they will carry, it will be provided into the lithosphere. They all will lose their heat to the lithosphere. So gradually the lithosphere become hotter and start to melt. So gradually lithosphere कौन hotter ହେଇଯିବ तापर melt ହେବା start କରିବ. So एठी temperature suddenly न बढ़िकी gradually increase करे, and eventually it will touch the solidus. And suddenly ଯଦି तुमको magma ଚାରିଆଡୁ ଆସୁଛି तो ये ଜାଗାରେ ସେ magma ଟା ରହିଲା, तो magma ଟା ରହିଲେ ଯେ ସେତିକି heat ଅଛି या surrounding rock କୁ ଗଲା, तो surrounding rock gradually ଅଧିକ hotter ହେଲା and eventually melt କଲା କାହିଁକିନା plume ଟାରେ କ'ଣ continuous magma supply ଆସେ. ତାପରେ ଏଠି hotspot ହେଇକି volcano ହେଇକି ତୁମର island arc ହଉ କି ତୁମର volcanic arc ହଉ ଯାହା ବି produce ହେଉଛି during hotspot, continent part ରେ ହେଲେ ବି ହେଇପାରିବ, oceanic part ରେ ହେଲେ ବି ହେଇପାରିବ. But in case of convergent plate boundary, it is because of addition of water to the subducted slab. So subducted slab रे water addition हुए, तो water कौन करे that will decrease the melting temperature. So से melting temperature को decrease करा, तो ସେଥିପାଇଁ solidus temperature ଟା decrease करे जाए, it will touch the geotherm. तो से जगह से melt हुआ start. तो subducted slab तळକୁ जाउची से dehydration reaction होची, तेरा hot temperature बढ़ुची, सही जो molecule water release होचंदी that will within the plate, so plate रे रहंती and तार temperature को तारा melting temperature को decrease कराते. तो dehydration सबले मना हुए कि यदि कौन जगह रे तुम्हारा dehydration होची hydration तक होती, जेतले water addition होची because of dehydration reaction, जति भी तुम्हारा hydrated molecule थे से माने water release करिवे सेटा से plate रे add हो and तारा temperature melting temperature decrease हो, so that की solidus को touch करि परिबो and it will generate magma and it will rise. If तुम्हारा island arc volcanic arc जहाँ produce हो, that will be explained by this phenomenon. ए phenomenon पूरा हम explain कर परिबा, पूरा हम कहते magmatic underplating. This phenomenon or here both are तुम्हारा magmatic underplating. So these are different processes where magma will generate and come to the surface. So classification of igneous rock. So igneous rock are classified in different ways. So it can be classified in genetically by genetical classification जोटा कि can based on color based on texture based on chemical composition, and there are IUGs and other serial tabular classification, task classification. There are different scheme of classification. So genetic classification, or you can say on the basis of depth of formation, the three types of igneous rock: volcanic rock, plutonic rock, hypoglycemic rock. So volcanic rock, it is extrusive, form at the surface, which is characterized by fine grain. Plutonic is form at a greater depth, medium to coarse grain. Hypoglycemic rock, to take form in shallow depth, it also is medium to fine grain, medium to fine grain, on the basis of depth of formation. Then in terms of color, we use lithocratic, mesocratic, melanocratic, hypermelanocratic. It's very important. So leucoplatic is very for a lighter color metal or lighter color rock which contain less than 10% of mafic metal. So mafic means magnesium and iron. Always remember where we will use the term mafic, that means MgFe. The mesocratic it contains 30 to 50% mafic metal, melanocratic 60 to 90%, and hypermelanotic more than 90%. More than 90% is called ultramafic rock. You can call mafic. So more than 90% if it is contained mafic metal, it is also called as ultramafic rock. So classification based on alumina content, by you can say alkali content, alkali and alumina content, that is alkali lime index at alkali lime index. Sand scientist, he classified the igneous rock into three types: for alkaline, for aluminous, meta aluminous. So for alkaline, where Al2O3 it is less than Na2O plus K2O. That is for alkaline. For aluminous, Al2O3 greater than CO plus Na2O plus K2O. For alkaline, alkaline percentage अधिक रहुछि, for aluminous aluminum percentage अधिक रहुछि from Na2O K2 or for CO Na2O K2. Beta aluminous, where Al2O3 it is less than CO plus Na2O plus K2. Al2O3 will be less than CO plus Na2O plus K2. But Al2O3 only it is greater than Na2O plus K2. If you add CO, then it is less than Al2O3. If you remove CO, then Al2O3 will be more than Na2O K2. It is meta aluminous. So the molar alkali ratio you take on the Na2O plus K2O by Al2O3, it is called as the for alkalinity index. Sometimes you will very आगे This comes to IBIS classification. Normally, I may represent currently in a triangular composition diagram. What we have started in ACA package diagram. So in a triangular composition diagram, we take three vertices here. So three vertices we represent three minerals. तीनटा mineral represent करा दें. So X, Y, Z तीनटा example लिया है जी. तो मन रखो X vertices रे X होच 100%, Y Z रे तार value होची 0. जेते तुम्हें याद को जीवा towards X from Y Z X रे value बढ़ी. Suppose X होची एठी 10. ए लाइन ने पूरा X रे value 20. ए लाइन ने X रे value 30, 40, 50 एमती बढ़ी बढ़ी जीवा. Similarly Z रे value X Y line ने 0. Then जते increase करिवे याद को ये जो line पूरा parallel to XZ that will indicate Z value. And Y on XZ 0, the parallel to XZ line will give the composition of Y and it increases towards the Y. Understood? So the pointer कहलो what is the percentage of X, Y and Z? तीनटा लाइन टान दब ये जो लाइन टा अछि इट इज पैरेलल टू XY. इट इज पैरेलल टू XY. तो XY यदि एटा हला ताले टू लाइन XY को पैरेलल से Z रे परसेंटेज दब. तो ये लाइन टा कोन में 10 20 30 40 50 60 70. तो ये लाइन टा होची 70. तो Z रे वैल्यू ई जो केते 70. आ गोटे लाइन देछि एमती ए पॉइंट में इंटरसेक्ट करछि. So A line का पैरेलल से XZ से तो पैरेलल है. तो XZ से तो पैरेलल है से Y रो कंपोजिशन दबा. तो XZ लाइन रे Y रो वैल्यू 0 तापर गोटे लाइन एठी 10 दे. तो माने Y रो वैल्यू केते हेगला 10. तो जे दीटा पाई गला तो ऑब्वियसली और X रो वैल्यू 20 ही हबो. ठीक আছে তুমি দেখি দিও ଆଉ ଗୋଟେ ଲାଇନ୍ this is another line এটা ଆଉ ଗୋଟେ ଲାଇନ୍ ତ এই লাইনটা কোন হଉଛି এই লাইনটা it is parallel to yz এটা yz को parallel ଅଛି তো yz को parallel ହେଲେ এটা তবে x ର composition 10 20 ବୁଝିପାରିଲ x y z percentage at this point. So this triangular diagram, in this triangular diagram we represent the rock. So but we always normalize them to these three components. हमको ये तीनटा component through रे ही ताको normalize करें पड़ेगा. Like कि गोटे igneous rock अच्छी, it may contain more than 3 minerals. But आमे जो तीनटा mineral तार major अच्छी, ते तीनटा mineral को नेक ताको represent करेगा. So से तीनटा mineral इसमें तार percentage recalculate कराते. So how we will do that? We'll take an example. Suppose कि ये तुम्हारा x y z terms ना हो. तो suppose उटे rock रे x अच्छी तुम्हारा 10%, x अच्छी suppose 20%, y अच्छी 30%, z अच्छी 20%. Then other p ରହିଲା 10%, q 5%, then other the rest is 15% रहे, है ना? Total missing rock analyze करा ला that is equal to 100%. But we only need these three to represent in a XYZ diagram. So any composition that is represented here must be added to 100%. तो देखो जरा add अब क्या 100% होगा. But these three compositions not 100% here. it is 100% नहीं. So we have to recalculate them. अब हमें recalculate करिए पड़ेगा. So suppose केम में recalculate करिबा outer percentage x by x plus y plus z. It will give x percentage y x plus y plus z by z by x plus y plus z. So if you recalculation हम करिबा we will get new x percent, y percent and z percent. They will be added up to 100%. Then we can represent them in the triangular diagram. Similarly, with igneous rock it contain many minerals. So ଆମର जो required तीनटा mineral through रे हम rock को represent करछंती, we always have to normalize them or we have to recalculate those percentage to 100% so that we can represent them into a triangular diagram. So in these values for x, y, z, they must total 100%. If they do not, they must be normalized to 100%. This is done like 100 by x plus y plus z. As an example, suppose A, point A, so this point A IIT. Point A has a composition x 9, y 2.6, z 1.3. So you have to normalize this value to 100%. That will multiply each by 100 by 100 by 9.0 plus 2.6 plus 1.3, that is 7.5. So if you normalize them, it will be 70%, 20% and 10%. So now these three will add up to 100%. Now we can represent them at point A. But we cannot represent these values. We have to normalize them. Okay. So we have to calculate the percentage. Similarly, by this calculation, we represent IIT's classification. Which consists of quartz, alkali feldspar, plagiarized feldspar, and mafic metal. There are two triangles like this. They are joined like this. One is QAP triangle, where Q stands for quartz, A for alkali feldspar, P for plagiarized feldspar. Then we have F. QAPF. F for feldspar third. That is QAPF diagram. So this is the QAPF diagram of plutonic rocks or coarse rock. So you have to memorize the diagram. तुम्हें diagram टा पूरा completely मन रखने पड़ेगा. So QAPFAP. So why these are two diagrams? Because quartz and feldspar third they cannot occur together. So in place of the quartz or in quartz diagram, feldspar thread is absent. In FAP diagram, quartz is absent. That's why I have to draw two diagrams, two triangles. That joined by AP line. That rocks are represented. You have to remember granite, granodiorite, tonalite. So tonalite it has a less alkali percentage. From this you can analyze the composition. Suppose granite has more alkali feldspar than plagioclase feldspar. Granodiorite it has more plagioclase feldspar than alkali feldspar. So from the diagram you can analyze these things. You suppose कि monzonite it has both alkali and plagioclase of same percentage. So तुमको इटा completely मन रखने पड़ेगा. So this is the volcanic diagram. That is plutonic, it is volcanic. This is another classification, that is serial doubler classification. Critically में मन रखो what is the plutonic and volcanic equivalent of rock. So तीनटा field रे division कराई थी saturated, undersaturated, oversaturated. So composition is quartz, feldspar, feldspar, feldspar third plus feldspar, feldspar third, then mafic metals. So हमसे कोको mineral तांको under रे आसुची. And what is the plutonic equivalent and volcanic equivalent? तुम्हें granite पहले granite में तुम्हें volcanic equivalent rhyolite पहले. These are written here, so you must know one. That's why there are ultramorphic diagram. So it has ultramorphic rock diagram, olivine, orthoparison, clinopyrison. जोटे rock में तुम्हारा olivine, orthoparison रहले ताको हार्जवर्गाइट कुआ जाए. कि olivine, clinopyrison रहले ताको वेयरलाइट कुआ जाए. Orthoparison, clinopyrison रहले ताको वेबस्टराइट कुआ जाए. है ना? आदि जिन्ना का मिसिंग रहे तारे लेजोलाइट कुआ जाए, नॉले olivine, वेबस्टराइट कुआ जाए. जो olivine percentage कम थी वो ताले olivine, वेबस्टराइट 30% कम थे नॉले लेजोलाइट कुआ जाए. तो triangle टा completely मन रखो. It is a very important triangle. এটা बहुत important है. तार सहित you can calculate more of plagioclase OPX diagram. लेकिन plagioclase और orthoparison रहले तब कौन दी norite. plagioclase और clinopyrison रहले तब कौन दी gabbro. only plagioclase रहले तब anorthosite कौन दी किसी monomineralic rock. The combination of those diagrams. The diagrams of combination है. तासते एटा तुमको नेक्स्ट क्लास रे जणेबी केमती पढिबो केम मन रखिबो. तो फॉर तुम्हें अल्ट्राफिक रॉक डायग्राम एटा अल्ट्रा बेसिक रॉक डायग्राम इसका सीरियल टेबल देन आइविजेशन दिटा डायग्राम. एटा कंप्लीटली सब मन रखो.